Well, we were just picking to with Carrie that this week's material was pretty much just including more means, and it's the same procedure, and using a new spreadsheet as well.
Right. Let me get my folder out.
Okay.
I just barely walked in the door here. So. All right. Keep doing it.
Okay, so whenever you're ready, then.
I'm ready. As ready as I'm going to be.
Okay. So then we can move on directly to part 2 of the preparation assignment. It says, Nava, according to William Butler, yet she is the Gaelic muse, for she gives inspiration to those she persecutes. The Gaelic poets die young, for she is restless and will not let them remain long on earth. One study designed to investigate this issue examined the age of death for writers from different cultures and genders. 3 categories of writers examined were novelists, poets, and non-fiction writers. The ages of death for female writers in these categories from North America are given in the document data. You would like to determine if the mean age at death is different from any of the categories of writers. Use alpha equal 0.05 as your level of significance.
All right.
Okay, so the first question asks, what is the research question?
So I just put, is the mean age of death different from any of these 3 categories?
Yes.
Close enough. That's basically what I got. Yep.
And it says state the null and alternative hypotheses. So the null is all means are the same, and alternative one or more means differ from the other.
Right.
Yep.
Okay. Then next one it says to collect the data.
I just wrote down that they took the age of death for female American writers. That's the data they gave us, right?
Yep.
Yes.
That's what I put.
It's not explaining pretty much from where and what the process was. It's just they collected data.
Yeah.
It's not specific. Okay, so then number 3 it says describe the data. For this one, let's just type in there the general statistics, the null hypotheses, and all of that information.
Right.
Yep.
The sample mean, standard deviation, all of that. And then having yes, pretty much those things. I don't know if it did something different in here.
Yeah. Do we need to include anything? What we had the mean, the standard deviation, and the sample size. That's all we need to include,
Yes.
isn't it?
Yeah, that's what I have.
Mm-hmm.
Yeah, because I put more information down there than what I think was necessary, but
yeah.
Okay, so then for number 4, to make inferences, letter 8 says what type of hypothesis test is appropriate? The one we are studying at this time, the analysis of variances of several means. Then it's asking letter B, what are the requirements for this test?
The requirements were that the data was normally distributed, right?
Correct.
The variance wasn't 4 times greater. So, yeah, QQ plots help show.
Right, that's what I used.
They're not perfect by any means, but they're close.
Yes.
Mm-hmm.
That's what the written says. The QQ plot, it's not going to be very specific, but if it is related to you, that will work.
Mm-hmm. Right.
And yes, then for the variances, if the greater one is, yes, if the smallest is no more than 4 times the greatest one, those are equal, correct?
Right.
Mm-hmm.
Right. So I got confused on the degrees of freedom because, when I went to check my answers, it said that it was 2,000 and something, but my Excel spreadsheet said that the degrees of freedom were like a total of 122.
Yeah, I think it was a 2 comma and then also 120. There's 2
Yes.
degrees of variation.
Oh,
Degrees of
okay.
freedom. I saw
Okay.
that too, and I was confused, but
Those are two different degrees of freedom.
Okay. Yeah, I was very confused with that.
yeah,
Yes,
so the 2 and
we
then
have
both
two.
together.
Okay. So then letter C, it says, are the requirements met for this test? And then for this one, we needed to do the QQ plots to verify if it was normally distributed, and as well the calculation for the variances to verify if those are not larger than what the requirement is asking for. So then with this one, I come up with yes, the requirements are met.
Yeah, close enough, right?
Yes. Then for the next one, just I refer myself to the spreadsheet we were working with to get the test statistic, which for this one it's F.
Right.
And I came up with 6.563.
Yep, that's what I got.
Yep.
Then one is the one stating the degrees of freedom.
So yeah, that was the 2 and the 120.
Right. And that's
Correct.
why I got all sorts of messed up because I thought it was just combined 122.
Yeah.
Okay.
Yes. Okay. Then it says compute the p-value and compare it to the alpha level. So got for p-value, I got 0.002.
Right. Which is less than the 0.05.
Correct. So we conclude that we reject the null hypothesis.
Correct.
Right. Yep.
And for letter H, it says present your conclusions in the form of an English statement.
So for me, that would just be that at least one of the mean ages of death was different than the other means.
Yep. That's what I put.
Mm-hmm.
Sufficient evidence that at least one is different.
Yes, that's what I wrote down, that we have sufficient evidence to determine that. And then number 5, it says take action.
I don't. What do you really want to know for the action? Are you gonna try to change the influence of persons? Genre of writing. I mean, this is more. I don't know what to put on this one.
Yes, it's just giving us a question. With further study, we find the poets did die earlier than the novelist and non-fiction writers. What significance can you conclude from this? And we're saying it's just the time we die. It's not too much we can do with that.
Yeah.
Stay away from poetry.
Yeah, don't let your daughter do poetry.
Yes, you better go with non-fiction than novelists because novelists are dying earlier.
Yep.
Than the poets. Okay. Yes, but this one is just if we will evaluate different groups or maybe different countries that we can evaluate to compare country from country, maybe.
Yeah.
Right.
But then more than that, that's what I thought. Just different countries to compare in between.
Right.
Okay. So then if you want, we can move on then to the quiz.
All right.
Let's do it.
All right. Finally opened up for me. There we go.
Okay, so we will be using 2 different documents, the soccer shoes and the DASL hot dog nutrition.
Okay, I haven't opened those yet. Now, which is it? Is there its own probability applet, or are you supposed to use this?
This is the first one we use the normal probability applet.
Okay.
The same one with blue color on it.
Hot dog nutrition. Yum yum.
Mhm.
Wait a minute, where'd they go?
Okay.
Neither one of them opened up. Hold on just a second here. I'm waiting for them to open up. So my soccer shoes opened up, but my hot dog doesn't want to open up. I don't need the poets anymore.
There we go.
You guys ever have any trouble sorting the data out? They give you all these?
Not really.
Yeah, what kind of problems are you having?
I'm just wondering how you guys go about selecting the data to use. Because I don't have a mouse with this computer, so I have to.
Yes, it's because it's not given by column. It's just one column, and then there a certain number of each group.
Yeah, so it's kind of a slow process to gather the data.
Yes, because we need to make sure that we're selecting the right amount.
So what I've done is I've used one of the keyboard cheats, but I still have to go through and insert a column or a new row in between each category. And then if you use Control-Shift and the arrow button down, it'll take that first cell down to wherever the next break is, and it'll highlight all the data. But it's kind of a. I need to get a mouse is what I need to do.
Certainly, with the mouse, it's a lot easier than with a keyboard.
All right, so I should be ready to go now, in theory.
Yeah. So then we can move on then with question 3, and it says, in an analysis of variances hypothesis test, we reject the null when there is sufficient evidence to indicate that at least one mean is different from the others. It's true.
True.
Okay, so who wants to read number 4?
What requirement needs to be checked when performing an ANOVA hypothesis test? Mark all that apply. So this one, they all do need to be positive, is that right? And the data is normally distributed.
Mm-hmm.
Does the mean? Go ahead.
Oh, go ahead.
The question, do the means all have to be positive?
Well, with that one, it says just the F statistic is never negative, but it's not specifying that the sample means are all positive. So I would go with the other two. The data, it's normally distributed and variances are equal in each group.
Right.
Okay.
Because yes, I remember reading about having something never being negative, but that's the F statistic.
Right. That's why I was
statistic. Good call.
Okay, to check if a group is normally distributed, do the following. Scatter plot, histogram, or QQ plot. And I would say QQ plot for each one.
Correct.
Yep.
And the reason we do that is because the data, you want to know if the data is normally distributed. So the large numbers don't work with this one. Is that correct? Did I catch that right?
I think you're right, yeah.
Okay.
Okay, so then number 6, we assume the variance in each group is the same if the following happens. Then it says the largest variance is less than 4 times the smallest variance. It's second option going down. It's less than 2 times. Yes, the largest variance is less than 4 times the smallest variance.
Okay. The null hypothesis test is equivalent to conducting independent two samples t-test between every pair of samples. There are 3 pairs. 1, 2.
That'd be.
This test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? There are 2 pairs, right? Because we have 4 different samples.
Or is it 6 pair?
6 pairs.
6. 1, 3, 1, 3, 1, 4, 2, 3, and 2, 4.
And then 3,
Okay.
4.
Hold on, and then.
Yeah, so
Is that correct?
So it should be 6, right?
Yes, we have 1, 2, 1, 3, 1, 4, then 2, 3, 2, 4, then 3, 4. 1, 2, 3, 4, 5. Yeah, 6. So for the next one, we need to use the soccer shoes. It just was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 grips. Each row represents a kick from 10 miles away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller number are more accurate. So what is the minimum smallest variance for the 6 grips? Okay, let's type this on the spreadsheet. The smallest one I am getting, it's for the variable 3, and it's for 27.208.
That is also what I show.
Yes, it's close to the first group, which is 27.358.
Mm-hmm.
Okay, so are you talking about for variances, Kevin? Is that what you said?
Yes.
Or for mean? Sorry, let me go back to the question here.
Mhm.
I just remembered that my boss gave me a wireless mouse today at work.
Wonderful.
Yeah, I'm like,
That will be a big help.
let me plug it in and see if it works.
Okay.
Oh, okay. What is the minimum smallest variance for 6 groups? And you said 27.208?
Correct. It's for variable 3.
Okay.
Next question is asking us what is the maximum largest variance for the 6 groups? And that one is for variable 4, 53.158. That's what I'm showing here.
Me also.
53.158 variable 4.
So then it's asking us if the test for equivariance is satisfied for this data. It's true because it's no more than 4 times,
Right. So true.
or
Okay.
at least twice. Let's ask question 11. Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Let me jump to that line.
Okay.
QQ plots.
Okay. So the first one looks normal.
Mhm.
Okay.
Let's go with the second one.
Second one looks fairly normal. There's a couple of smaller variances, but
Yes.
not too.
Yeah.
Let's do number 3.
3 looks fairly normal, closer than 2.
Yeah.
Mhm. Let's go number 4. Yeah, as far as well looks normally distributed as well.
Yeah.
Number 5.
I would say so far I got one more to get through, right? That they're all close enough, even though they're not perfectly normal.
Yes. Number 5,
Yeah.
it's kind of. And finally, number 6.
Six is ugly.
Yes, it's kind of 5. Those are close. 5 and 6 are the most that I'm not too much, but yes,
Right,
kind of fall into.
I think for the most part they're pretty approximately normally.
It's just at the beginning for 6, but then the rest of the QQ plot is normally distributed.
Yeah.
Okay, so then for question 11, we can conclude that it is true, approximately normal.
True.
Yeah.
It says, question 12, perform an analysis of variances test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the text again. What is the p-value when we remove the SOX data? Let's check. Yes, the p-value is 0.081. Let's remove the 6.
So I get 0.309.
I'm getting.
So that's variable 6, right?
Yes.
That one out?
Yeah.
Correct. Yeah. I got 0.309 as well.
Yeah.
309. Did you get the same, Sean?
Hold on just a second here.
Okay.
My computer give me grief. I'm just gonna do it this way. Clear contents. Okay. Now, you had 0.309?
Yes.
Okay, that's what I got.
Wonderful. So for number 13, it says the test statistic for an analysis of variances hypothesis test is an F statistic. Is the p-value the area to the right or left the F statistic? It's the right side.
That should be the right side. Yep.
So it says researchers had consumer reports and analyzed 3 types of hot dogs, namely beef, poultry, and meat. Most pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file. Is this data file to answer the remaining questions? Okay, let me clean that one up.
So what are we looking for first?
So I think we're gonna examine the calories first.
first? Are we just doing a QQ plot? Is that what they want first?
I think so.
Number 14 says, let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use analysis of variances have been met. Let's check then with that one. For beef. For beef, I would say is kind of normally distributed.
Right.
Yeah.
Meat. For meat as well, it's at the beginning that it's not too much, but then the rest of the QQ plot is showing it distributed.
Right.
Yeah. Yeah.
Let's go with poultry.
Poultry looks pretty similar to the meat one.
Yes. True.
So none of them are exactly perfect, but it's still pretty darn close, right?
Yep.
Yes. That's kind of at the beginning. Then we need to get the variances so we can verify it as well.
So we're going with the first answer then on 14. The assumptions have been met. It's safe to assume which groups comes from normally. Is that correct?
We need to verify as well the variances if those are not. If those are, if the largest one is no more than 4 times the smallest one. I'm just going to type that in here. First. Second. Yes, and so variances are equal. The largest one is 636.846 and the smallest one 508.566.
Yep.
So yes,
Right.
that requirement as well, it's complied.
Right.
So we can assume have been met.
So the first one.
Yes. Because then it says 15, run an analysis of variances test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that degrees of freedom are 2 and 51, that F statistic is equal to 16.074 and p-value 0.000 with a level of significance to 0.05. What conclusion can you draw? Let me go over to that one. Yeah, 16. P-value is 0.000. Degrees of freedom are 2 and 51. It will be the last one, right? That we have sufficient evidence to claim that at least one of the hot dog types has a different number of calories than the other types.
Right.
Okay, so who wants to read number 16?
Hold on a second. Let me ask you a question.
Go ahead.
Here. Make sure I'm reading the chart right, because I'm getting it. Oh, that's why. I've got the e to the -6, which means that there's 6 zeros in front of the 3.
Mm-hmm.
Right. Okay.
Scientific notation, yes.
Scientific notation puts all those zeros out in front.
True.
Right, so it's about 0. Got it. So with that being said, we have sufficient evidence to claim that at least one of the hot dog types has a different mean number, which is basically rejecting the null.
True.
Sodium levels.
Yes, now let's go with sodium. Need to do exactly the same, but now for this one.
All right, sodium, copy. We got to tell you that going from not having a mouse for just about 2 years to having a mouse, what a difference.
Certainly. Okay, for the first one, it seems, well, approximately normally distributed.
Okay, yep.
Forward.
Just getting it now.
Second one.
Okay.
So, second one, it's fairly approximately distributed, more than the first one.
The third one's a little funky.
I'll check on the third one. Yeah, as the third one, it's not too much. It's different at the beginning as well. Okay, so now let's do the variances.
The variances are the highest one's 10,492.871. The lowest is 7,180.750.
Right.
So with that being said, it's not 4 times greater, so those are normal.
Right. So it should be the first one again. The assumptions have been met.
I would say, I don't know, is it the second one this time? Or the third one, I mean? How close was the third one? That's the question.
Assumption I've met, the second assumption groups comes from a normally distributed population, and we also assume the variance where the assumption have been met and not been met.
I just don't have enough experience with QQ plots where you say that it's far enough out.
Yes, I would say it is okay.
I'm fine with going with number 1. I don't know enough about QQ plots to.
Right. I don't know either if it needs to be like an obvious where it's way out there or where it's kind of.
Because they both seem to be a little diagonally. They're not perfectly parallel, but are they close enough?
Right.
Let's go with the number 1, like you said, Kerry.
Mm-hmm. So that's number 17. Despite the possible problem with the QQ plot for poultry, you decide to use analysis of variances to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test?
Aha. Okay.
But that's when it's given us a hint for the old one.
Yeah. So should we change that previous one?
Okay.
So which means, never mind, while it is safe to assume each group comes from an early rule, we cannot assume the variances are equal. We can assume that variances matters not the sum each group comes from an early distributed.
So it'd be that third one then, right?
Yeah, it's the third one because the third one is letting us know variances are complied but not completely Q plots.
Right.
And it's given us as well, it's the one from the poultry, the one we discussed was not too close to falling to that expectation. Okay, so let's go with the third option then. And then despite that, just going to check the p-value. I do have 0.179.
What I have also.
What I have as well. So we do not reject the null because the p-value is greater than the alpha.
Mm-hmm.
Right?
Correct.
So that means that we have sufficient evidence to claim that all three hot dog types have the same. All means are the same.
So that's sufficient evidence to claim that all three hot dog types have the same sodium level.
Hold on. We do not have sufficient evidence to reject the claim that all. That's what it is. That's
right. Yeah, I think the
so I was
second
thinking
one.
the second option because we do not have, because we're failing to reject.
Yeah. If I remember correctly, as we've gone through the statistics class, you never have sufficient evidence to accept it. You don't have enough evidence to disprove it.
Right.
Correct.
Okay.
Okay, so let's go ahead and submit and take a look then. Okay, we got them all.
My computer's not doing what it's supposed to do here. Come on. It's been a long day.
Those are computers. Certainly.
All right, mine shows we got them all too.
Me too.
Good.
Nice.
Looks good.
Yes.
All right.
So the next time we need to get ready for the quiz. I haven't read the instructions. Do we need to take the first attempt alone and then go with the second attempt together? Haven't read that section.
For the exam?
Correct. Yeah,
so for the
yeah. I'm not sure.
Yeah, it seems like last time there was something that we were supposed to do first, and then we take it a second time together. Not the actual exam, but kind of the
practice.
The practice, yeah. I think you might be right that we are supposed to do that first and then do it again together.
Yeah. I will go ahead and read it and send you an email just to confirm.
Sure, that'd be great.
Okay, so then I'll post the link just once the video is uploaded. So thank you for your help as well.
Yes, thank you.
Have a good night, guys.
You too as well.
See you Thursday.
Yeah, bye.